Okay, number 8, integrate a complicated looking thing with a load of radians involved with an unknown limit. Getting interesting, this question. Quite hard, but you get 6 marks for it, so it's definitely worth having a pop at it. Get some of those marks at least, even if you don't get all 6. So, okay, I'm going to integrate between pi over 8 and a, whatever a may turn out to be, 5 sine of 4x minus pi over 2. Okay, and they've told us the answer. This will come in useful later, but I'm just going to start from here, always write dx, and see where I get to. Now, to integrate something like this, really, I'm thinking, what would I differentiate for this to be the answer? Integration being backwards the opposite of differentiation. What would I differentiate for this to be the answer? Okay, so when I differentiate cos, I get negative sine. Okay, that's close, that's close. When I differentiate 5 cos, I'm going to get negative 5 sine. So that's kind of close. If I differentiate cos of 4x minus pi over 2, then what am I going to get from this when I differentiate it? I feel like I'm getting close here. So I would get negative 5 sine. Cos goes to negative sine. It's on the formula sheet. Okay, differentiating here. Of 4x minus pi over 2. But this is a chain rule. So far, I've differentiated cos of something and got negative sine of the same thing. That's the outside function, so I have to multiply by the differential of the inside function. Now, this is actually really easy to differentiate. Don't get worried about pi. Pi is just a number. It's like 3.14159653. It doesn't matter. It's just a number. Differentiate the number 3 and you get nothing. It's gone, 0. So the differential of this bit is the differential of this bit. Differentiate 4x and I just get 4. Okay, so a bit of a chain rule there. Now, this is my guess. If I differentiate this, I don't quite get this. I've got a problem. How do I fix it? I need a negative at the start to kill off the negative. And I need to somehow be dividing by 4 to kill off this annoying times 4 that's popped up. So my answer will be this. This is the thing that I differentiate to get this, which is the same as that. Okay? So when I integrate this, this is what I'm going to get, because when I differentiate the answer, I get back to where I started. Okay? So that's going to give me negative 5 over 4 cos of 4x minus pi over 2. And I'm going to evaluate that. So let's put plus c just for interest. We should normally put that. We won't need it in this case, but we'll see why. And we'll evaluate that between pi over 8 and a. Right. What does this mean? It means shove in the top number, a, first. So that's going to be minus 5 over 4 cos of 4a minus pi over 2 plus c. Take away when you shove in the bottom number, which is minus 5 over 4 cos of 4 times pi over 8 minus pi over 2. Well, this is looking a bit messy, but I'm sure it's going to sort of sort itself out here, and there's a plus c there. So you can see why I didn't need the plus c. It's because I've got plus c there, minus a plus c there, so they cancel out. Let's zoom in on this bit a bit. 4 times pi over 8, that works out at pi over 2. So I'm going to have that same thing, ditto marks, take away, right, negative 5 over 4 cos of, and we said that was working out at pi over 2 minus pi over 2, and we said the plus c's have cancelled out. So that's 0. That's 0. Cos of 0 is 1. So what have I got? I've got this same thing, minus 5 over 4 cos of 4a minus pi over 2. Minus minus is a plus. 5 over 4 times 1. And remember we got told at the start what the answer was supposed to be is 10 over 4. So let's get that involved now. That answer is supposed to be 10 over 4. Okay, so next thing I'm going to do, I'm getting annoyed by all these dividing by 4s. Let's times by 4 everywhere. And I'm going to have negative 5 cos of 4a minus pi over 2 plus 5 equals 10. Let's subtract that 5 and then divide by that 5. Divide by the negative 5, why not? And I'll have cos of 4a minus pi over 2 equals, so subtract the 5 and you've got 5, divide by 5 and you've got 1, divide by minus 5 and you've got minus 1. Okay, now I'm going to do inverse cos. Inverse cos of negative 1, and of course I've got these silly pi things, so I'm talking about radians. So inverse cos of negative 1, normally on the cos graph, that would happen at 180 degrees, which is pi radians, right? So what I've got here, inverse cos, and I've got 4a minus pi over 2 equals inverse cos of negative 1 pi. Add that on there, and I've got 4a is going to be 3 pi over 2, divide by the 4, and I'm going to end up with a equals 3 pi over 8. How nice.